Okay, so class, now we are moving on to graphing cotangent. So we have a table of values that we're going to plug in for our x value, so our angle. So first we're going to find cotangent of 0. So at the angle 0 on the unit circle, the coordinates are 1, 0, and on the unit circle, cotangent is the x over the y coordinates, and so it is undefined. Then we're going to find cotangent of pi over 4, and at pi over 4 it's root 2 over 2, root 2 over 2, and so we do x over y and we get 1. And then we're going to find at pi over 2, where the coordinates are 0, 1, we're going to do x over y, and we get 0 over 1, which is 0. So our cotangent of pi over 2 is 0. So go ahead and plug in all of these values into cotangent and use the unit circle to complete this table. So pause the video. Okay, so I went ahead and filled it out, and I'm going to plot these points just like I did with tangent. So I'm going to plot the point 0, undefined. Well, at 0, I'm going to have a vertical asymptote, which is undefined. So I'm going to draw in my vertical asymptote. At pi over 4, I have 1. So I know that right here is 3 over 2 pi, and I can count, so halfway there would be 3 pi over 4, and so I know that this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and so on. So at pi over 4, my y value is 1, which you can see. At pi over 2, it's 0. 3 pi over 4, it's negative 1. At pi, it's undefined. At 5 pi over 4, we're at positive 1. And at 3 pi over 2, it's 0. And if we continued, we'd have negative 1. And then at 2 pi, we would have another asymptote. And if I had my table going in the opposite direction, I would likewise have these values marked as well. Just like it was with tangent, you're going to have a middle point. You're going to go over one x-axis value and go up the amplitude, and then right one x-axis value, and then down the amplitude. And then on either side of that, you're going to have your asymptotes. And this is going to be what one period is for cotangent. And you can see that one period of cotangent is pi, or in general, pi over b. And our x-axis scale is always going to be the period over 4. So it's going to start off generally as pi over 4 until you have a change in your period, as you'll see. Our vertical asymptote, it's always going to be x equals, and you look for the first non-negative asymptote, and your first non-negative asymptote is right here at 0, plus the distance between your asymptotes, and the distance between your asymptotes are always going to be every pi, or every period, so it's going to be n pi. Of course, you don't need to write the 0, so you can just say n pi, or pi n, indicating all multiples of pi. The domain is going to be all real numbers except your asymptotes at x equals n pi, because it's not defined where all the vertical asymptotes are, because that's where the function is undefined. The range, remember we go from negative infinity all the way up to positive infinity, and there's no breaks in it, so it goes from minus infinity to infinity, or in other words, all real numbers. And those are the basics of graphing cotangent. So let's go ahead and move on to the first example here. So for the first example, we want to graph two periods of this function. And for this one, we're going to have a period change because I have that b is 1/2. I'm going to have a vertical change because my d is 3, and an amplitude change because my a is 1/2. Okay, so let's go ahead and go through that. The period is going to be pi over b, which is pi over 1/2, or in this case my period is 2 pi, My x-axis scale is period over 4, or in this case it's pi over 2. Okay, the general shape is on the the y-axis. There's an asymptote, and then 1 period away there is another asymptote. So this is what 1 period looks like. Cotangent starts up high, goes to the middle, and goes back down. So you're going to have the middle point, which is your midline, and then you're going to go 1 box in either direction, and then this is going to be what your amplitude is. Okay, so it looks just like a negative tangent function with a phase shift of pi over 2, and in fact it is. Okay, so we are going to start off, since there's no horizontal shift, I know that there is a vertical asymptote here. And at 1 period away at 2 pi, I'm going to have another asymptote. So I'm going to go 4 boxes over. I have a vertical shift up 3. 1, 2, 3. So at 3 is kind of where my midline is. Okay, so I know my midline is here. And if you want to draw in your midline, you may. Sometimes that's helpful. So between my asymptotes halfway is going to be my middle point. And then I'm going to go left 1 box and up the amplitude. So I'm going to go left 1 box and up the amplitude, which is 1/2. And then from the middle, I'm going to go right 1 box and down the amplitude. So I'm going to mark those values 3.5 and 2.5. And it's really, really squashed, but I'm going to do my best to do some sort of upward facing curve and some sort of downward facing curve for tangent or cotangent. And I'm going to label my values along my x-axis for all of my key points. So I have 1 pi over 2, pi, 3 pi over 2, 2 pi. I counted in pi over 2s because my x-axis was pi over 2. My period was 2 pi, so the distance going along here is 2 pi. So this is 1 period. And I need to graph 2 periods. So I'm just going to continue. So I'm going to count 1, 2, 3, 4 more boxes. And that's going to be 4 pi. Midway on the midline would be where 3 pi is. And I'm going to go back 1 box up the amplitude and forward 1 box down the amplitude and draw in my curve and make sure I put my 1, 3, 5 pi over 2 value in, my 7 pi over 2 value in. So all of my dots have values marked. So I'm going to write the equation of the vertical asymptote. It's going to be x equals the first non-negative asymptote, which is here at 0, so I'm not going to write it, plus the distance between the asymptotes, and the distance to the next one is 2 pi away, so 2 pi n, or n times 2 pi. The domain is going to be all real numbers except where my vertical asymptotes are, because it's not defined there. So all real numbers except x equals 2 pi n, and the range goes from -infinity up to infinity, or all real numbers. Okay, so that is the first example. Let's go ahead and try the second example. So for the second example, we are going to graph a negative cotangent function. So this negative tells me that there's going to be a reflection on the x-axis. This -4 tells me that D is -4, and that's our vertical shift down 4. B is 1, so there's no change in the period. So the period is pi over 1, or pi. My x-axis scaling is period over 4, or pi over 4. Okay, so typically our cotangent starts on the y-axis, and it is up high, goes to the middle, and comes back down where we have our key points that revolve around the midline. When we have a reflection across the x-axis, what happens is this chunk reflects downward, and then the other chunk reflects upward. So we're going to have a negative cotangent function and a positive cotangent function. And a negative cotangent function, since it rises from the left to the right, looks just like a tangent function. So it'll be like a tangent function, but with a phase shift in it. Okay, so again, no phase shift, so I know cotangent has its first asymptote on the y-axis. I'm going to be graphing my negative cotangent function, where I have the middle value and then the two values with the amplitude on either side of it. So I'm going to count 4 boxes over, and I'm going to find the middle, and then on the middle I'm going to shift down 4 for the midline. A negative cotangent shape. From the middle, you go left 1 box and down the amplitude. So I'm going to go left 1 box and down the amplitude of 1, and then likewise I'm going to go right and up 1. So this is the shape of a negative cotangent function. So I'm going to draw my shape in to make it look curved, not a straight line. And I'm going to fill out my period as pi, and my x-axis scale is pi over 4. So I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So I counted by pi over 4s, and I'm going to graph my second period. So I have my second asymptote, which is pi apart, because my asymptotes are all 1 period away. My midline was down 4, so halfway between my asymptotes is going to be my middle point resting on the midline at -4. My amplitude is 1, so I'm going to go left 1 x-axis value and down 1, and right 1 x-axis value and up 1. And I'm going to draw in my cotangent curve. And I'm going to make sure my y values have all their dots have values marked. So my vertical asymptote equation is x equals the first non-negative asymptote, which is 0, plus the distance between the asymptotes, which is 1 period, or pi n, or n pi. The domain is going to be all real numbers except the asymptotes at x equals n pi. And the range starts at -infinity and continues all the way up to +infinity, or in other words, all real numbers. So that is how we graph cotangent and its reflection on the x-axis, negative cotangent. I will see you in class. Have a good night.